Okay, so part 2 of the lesson on 2.8. So we just got done solving a system of equations. We did it by graphing, where you find where they intersect. Remember, you could have two solutions, one solution, or no solutions if they don't cross ever. Then you could do by substitution. So this is what it looks like using substitution, where you plug one into the other, solve for x, and then plug it back in to solve for y. Again, you could have one solution, no solution, imaginary solutions if you wanted to work it all the way out. So all that stuff still applies. Now the last thing we need to go over, well, not the last thing, the last two things we need to go over is solving quadratic inequalities and then word problems. So with a quadratic inequality, we start by solving it as if it were an equation. So if this was an equation, we would solve it by setting it equal to 0. Clearly it's not, so we will minus a 6 on both sides so that it is equal to 0. So minus 6, that gives you x squared minus 4x minus 5. Remember, we're solving it, so we're just going to pretend like it's equal instead of a greater than. Factor this in order to find the solution. So this would be x minus 5 times x plus 1. So you get x is equal to positive 5, and x is equal to negative 1. So 5 and negative 1 are the answers that we need for the solution. The last part is we need to figure out the inequality, whether it's a greater than or if it's a less than. So what we need to do then is, the easiest way to picture it is it's going to be on the two-dimensional level, it's just going to be a number line. So I will make a number line. Let's make this a straighter number line. And then, so here is 5. Well, nope. All right, so negative 1 and 5. So then, your solutions are going to be on the 5 and the negative 1. And I don't know if you remember from Algebra 1, you could either have the arrows going outwards, that was like your OR type of inequality, or it could be an AND where you connect the two circles together. So to figure out whether the solutions are right here, everything in between the two numbers, or if the solutions are on the outside of the two numbers, what we're going to do is just choose a test value and see if it works. So I'm going to test, the easiest is usually a 0. So let's test a 0 to see if that works. So that's our test value, 0. So if I plug in a 0 into this inequality, so I'm going to plug a 0 in for x and plug in a 0 for x there. So then it's going to be 0 minus 0 plus 1 is greater than 6. So if I solve that, I would end up getting 1 is greater than 6. And then you have to ask yourself, is this a true statement or not? 1 is greater than 6? No, that's false. Because that's false, that means the 0 number that we tried to test is not part of the solution. Therefore, the solution has to be everything outside of those two circles. So to the left and to the right. So then, once we figured out where it's going to be, then we just need to write our answer out. So the negative 1, it's going to be x is less than negative 1, because all those numbers over there are less than negative 1. And for the 5, it's going to be x is greater than 5. And because the arrows go in opposite directions, that tells me that this is an OR type of inequality. If the arrows went towards each other, it would have been an AND type of inequality. Okay. So another example so that you can see how to do this. So you'll again have to treat it as if it were an equation. We'll add 3 to both sides. That way it's equal to 0. So add 3. Then that would give you x squared minus 10x plus 21 equals 0. Factor this in to be x minus 7, x minus 3. So you get the solutions x equals 7 and x equals 3. So now we have our solutions that are on a number line. Here it would be 3 and 7. You have to choose a test value in between these two numbers. Now, these were open circles on the first problem. These were open because there was no equal to on this one, but this one does have the equal to, so we're going to end up using closed circles on the 3 and closed circle on the 7. Again, choose a test value in between both of these. Doesn't matter which number. I would recommend that you do a whole number. If 0 is a possibility, that would be my recommendation, but 0 is not a possibility here. So I'm going to test with a 4. So if you test with a 4, we're going to plug in a 4 for this and a 4 here. So then that would give you 16 minus 40 plus 18. So 16 minus 40 plus 18. So that would give you, what, negative 6? So you get negative 6 is less than or equal to negative 3. And then you have to ask yourself, is that true or is that false? Well, negative 6 is in fact less than negative 3, so that's a true statement. So then, since that's a true statement, then that means negative 4 is part of the solution. So that means that the solution is everything that is in between 3 and 7. All these possible numbers in between 3 and 7. So here's how you write this is an AND type of inequality. There's two ways you could do it. You could do the same thing that we did on the first problem, except you write the word AND in between. But normally this is how AND inequalities are written. You do 3 and x in between and then a 7, and then it's less than or equal to. Because 3, it's basically saying 3 is less than all the possible values that are the answers for x, which is less than the 7. So in other words, in simpler terms, the solution is all the x values that can be between 3 and 7. All right, I'll give you two more examples. Now, these have a 2 in front of it, so we'll see if we can divide it out by 2, but looks like you can't. No greatest common factor on this one. So let's see. It's already equal to 0. I will take the 2 and the negative 15, multiply those together, so that would give me a negative 30. So to multiply to give me a negative 30, that would have to be a negative 6x and a plus 5x. So those add to give you the negative x that's in the middle, and if you multiply them, it gives you the negative 30, which is what you get when you do 2 times negative 15. Again, hopefully you should know that by now on how to do how to do this type of factoring. If you don't, it's not a good sign. Okay, so equals 0. Now it's 4 terms. Now we do factor by grouping. So I will do that. Factor out a 2x on the first one. Divide and I have x minus 3. On the second one, factor out a positive 5. Divide and I get x minus 3. So it looks like I can take out the x minus 3 from both of those because they both have it in common. I'm left with 2x plus 5 equals 0. So it looks like one of them is x equals positive 3 and the other one is x equals negative 5 halves. So if I pictured it in the form of a number line, then if I pictured it in the form of a number line, that would then tell me that I have, let's see, negative 5 halves would be here. You can change it to a decimal. That's fine. I just leave it as a fraction because it's easier for me. So this one has the equal to, so the circles are going to be filled in because these numbers are included in the answer. And I'm going to choose a test value in between. The easiest is always 0, so that's what I always check for. So I'm going to use a 0 in this case. So if I plug in a 0 for each of these x's, I get 0 minus 15. So it looks like that would be negative 15 greater than or equal to 0. which is a false statement. Since that's false, that means 0 is not part of the solution, so the solution has to be everything outside of those two numbers. So then I just need to write my answer. So x is less than or equal to -5/2, or you do have to write the word or, x is greater than or equal to 3. So these are all the possible solutions to this inequality. These are all the possible x values that you could plug in that makes the left side greater than the right side. One more time for this one. So again, try to divide out to 2, but looks like it doesn't go into everything evenly. So I will multiply these two. That gives me -10. So that means I'm going to split the middle term to be a positive 10x and then a -1x equal to 0. On the first one, you can factor out a 2x, divide and you get x plus 5. On the second one, you can divide out a -1, divide and you get x plus 5 equals 0. So I get x plus 5 times 2x minus 1 equals 0. So x is equal to -5 and x is equal to positive 1/2. So again, number line. -5 and positive 1/2. Let's see, it does not have the equal to, so I do not fill them in. I leave them open. Choose a test value in between. 0 is my favorite number to test because it's so easy. So plug in a 0, plug in a 0. So 0 plus 0 minus 5 gives you -5 less than 0, which is a true statement. Therefore, the test point does work, so that is part of the solution. So the solution then is going to be -5 less than x less than 1/2. There you go. This is an and inequality. There's another way to write it where it literally has a word and in between the two inequalities, but this is what you're more likely to see on an exam. If you do want to see it though, this would be written as x is greater than -5 and x is less than 1/2. That's the other way to write this inequality. But like I said, that's how it's normally done. Last one is a word problem. So Lori is partway up an escalator when her friend Evie realizes that she has Lori's keys. Evie tosses them from the ground up to Lori. There's a function that represents the height of the keys, and x represents how many seconds have passed since Evie tossed the keys to Lori. So first one says when the keys are thrown, Lori's hands are 9 feet above the ground and moving upward because the escalator is moving up at 0.75 feet per second. Write an equation of a function g of x, so I will start with that. So g of x, that gives the height of Lori's hands compared to the ground level. All right, so well, we already know that she is already 9 feet above the ground when Evie throws the keys, and then while the keys are in the air, Lori's hands are also moving because she's on the escalator, so it's moving up 0.75 feet per second. So then that would be 0.75x. Okay, so that's the equation that represents the height of Lori's hands compared to the ground level. Okay, now we're going to use those in order to solve, to figure out eventually to solve what it's asking for. So part B of the question says write the functions as a system of two equations. So that means basically just change the f of x to a y. So then if we change it, then it would look like, well, the keys in the air is y equals -16 x squared plus 25x plus 5, and then Lori's hands moving as she moves up the escalator is 9 plus 0.75x. And if you wanted to, you could have rearranged that one. Okay, so there's your system of two equations. Then it says find the solution to the system of equations. You can either use substitution or by graphing. So I'm going to see if I can do, well, I will show you how to set up the substitution at least. So if you do substitution, you're plugging, looks like we can just take this and plug it in for the y up here. So then that would give you 9 plus 0.75x equals negative 16x squared plus 25x plus 20 or plus 5. And it's all right if you had flipped this. So if you did the negative 16 equation first and then the 9 plus 0.75x, that really changes nothing. As long as afterwards you get this to be equal to 0. So if you get this equal to 0, so you got a minus a 9 and minus a 0.75, so that would give you 0 equals negative 16x squared. Subtract the 0.75 from the 25, so that would be 24.25x, and then minus a 9, so you get negative 4. And then once it's equal to 0, now you can do the whole quadratic formula thing, so then it would look like x equals, let's see, negative 24.25. And then, okay, so you can do all of that stuff, plus minus all of that, and then all over 2 times a, so 2 times negative 16. Or what you can do is by graphing this. So you would have to go on your graphing calculator, type both equations in, and then do that intersection feature that I showed you. If you don't remember how to do it, there's plenty of YouTube videos that you can search how to find the intersection of graphs on a TI-84 or whatever calculator you have. I went ahead and did these on Desmos, so I'm going to do that. Hopefully they're still there. Nope, they are not still there. So type it in, y equals negative 16x squared plus 25x plus 5, and then start a new equation. That one was 9 plus 0.75x. All right, so graph the two equations, and Desmos looks like there's the answer, 1.327 and 9.995, and then the other solution is 0.188. So if we interpreted this in the case of the problem, okay, so find the solutions to the system. So we already got one of them. Well, you saw on the graphing calculator, you would have it pulled up. So then the second one, the next part of the question says, how long after the keys are thrown will Lori be able to catch them? So if the keys are thrown, then this is represents the path of Lori's hand as she goes up the escalator, and then the keys being thrown. So let me check the wording of the question. So it says, how long after the keys are thrown? Okay, so the keys are thrown, and then how long after? Well, from here, this is 0.188. Well, no, that's not where they're thrown. They're thrown when time is 0. So time is 0 when they're thrown. The 5 just means that's how tall one of them is when they throw the keys. So then how long after it's thrown? Well, it's going to be 1.327. So 1.327 seconds. The 9.995, that was the height at which she caught the keys. Explain why this answer is reasonable. Well, I mean, if you got an answer of 10, that wouldn't make sense if somebody threw the keys and then that wouldn't explain why somebody throwing the keys and then their keys are in the air for 10 seconds. That would not make sense. Okay. So that's the end of the lesson. The homework I'm going to post on Canvas, and you have until Monday morning to turn them in. So you can do the homework if you want to watch both parts of the video, if you already watched both parts of the video, and then you can do the homework today, either today or tomorrow, and then you're going to turn it in by Monday into Canvas, just how we normally turn in homework assignments.